Okay, looking at number 19 on your test review. The first thing that is said here, FD bisects EFC, FC bisects DFB, that's all the given information. Now remember that anytime we use a word like midpoint or bisect or complementary or any geometry type word, very often the next thing we're going to do is we're going to say what that means. In other words, for FD to bisect EFC, that's this bisecting this, what it means is that it cuts it into two congruent angles. So that's what they're saying right here. And the same thing over here. If FC bisects DFB, then it cuts that into two congruent angles, which is what this is saying right here. These two angles are congruent. So those are definition of bisect. In other words, that's what it means to be an angle bisector. Let's say angle bisector. Or you could just say bisect. I'd be okay with that. So definition of an angle bisector or definition of bisecting angle or something like that. Excuse me. Now look at number 3. Step 3 is not very different at all from step 2. The only difference is in step 2 there are no M's and there's congruence markings instead of equal markings. This is the one going from congruence to equality or equality to congruence. You always say that's the definition of congruence, or congruent, in this case, angles, because this is all about angles. If we said congruent segments, you would have to see that we were talking about segments, and there's no talking about segments here. This is all about angles. Now looking at step 4. Step 4 says that this is the same measure as this. And look up above here in step 3, we said that both of those are equal to DFC. So remember, when you have two different things that are both equal to the same thing, and we say then they must be equal to each other, that's the transitive property. So transitive is fine for this step. And then again, same thing happens in the last step that happened earlier. We went from saying measures are equal to the names are congruent. In other words, these say almost exactly the same thing. The only difference is here we're talking with equals, here we're talking with congruence. So that's definition of congruent angles. Because this one says these two angles have the same measure, and this one says that means they're congruent. All right, moving on down here. Number 20, given angles 1 and 4 are congruent. So that's the first thing that's given. I'm going to mark that off because it gets used right away. And then the next thing that's said is that means their measures are equal. That's just like we just used up above there. That's the definition of congruent angles. All right, the next statement, 3 and 4 are supplementary. That's also from the given. So I'm going to put given. And then here's a math term, supplementary, and sure enough, the next step says, here's what that means. It means they add up to 180. So that's definition of supplementary. Step 5 looks a lot like step 4. The only difference is there's a 4, and there's a 1 in place of the 4. Well, when you're plugging something in place of something else, which we know that 1 and 4 are equal, so we can do that, that's called substitution. Angle 1 is substituting for angle 4. Okay, the next is, this doesn't really have much to do at all with number 5. So what I would do is go look at the picture. What kind of angles are 2 and 3? Those are vertical angles. Okay, so vertical angles are always congruent. That's the vertical angle theorem that says that. So vertical angle theorem tells me that vertical angles are always congruent or the same measure. If we were being really picky, I probably would have said congruent first and then changed it to measure. All right, and number 7, step number 7, again, looks a lot like step 5, except for one difference. This instead of that. That's the only change. There's a 2 where it used to be a 3, and we happen to know that 2 and 3 are the same. So we're plugging in a 2 in place of the 3. That's substituting it. So again, that's substitution. Now, the last thing is, why does that make the lines parallel? Well, let's look at what kind of angle pair 2 are. 2 and 1, excuse me. because those are the ones we're talking about. 2 and 1 are same side interior angles for lines L and M. If same side interior angles are supplementary, the lines are parallel. Well, here's saying that they're supplementary, so here's saying they're parallel. That's the same side interior angle converse. All right, I'm running out of time, so I'm going to go real quick with this. This is where we just do the same thing to both sides and give a reason. First thing I would do here is I would subtract 2x from both sides. I don't show the work. Minus 2x, that gives me 6x equals 6. Subtraction, property of equality. Remember, we write POE when we do that. I'm sorry, that goes right here. I'm in too much of a hurry. That goes right here. What would go for reason number 1? Well, we started with that. We were given that to begin with. So reason number 1 is given. This is subtraction, property of equality. Then what would I do next? I would divide both sides by 6. So that would be division, property of equality. And that's it for this page.